In the world of global infrastructure, there is a set of holy laws that every engineer, lender, and bureaucrat follows. If you are building a canal through a desert, a place where the sun is a physical weight and the soil has the consistency of powdered sugar, you line it. You encase that water in concrete, plastic, or specialized clay. You treat every drop like liquid gold because, in the desert, that is exactly what it is. To do otherwise isn't just considered bad engineering. It's considered a fiscal and environmental crime. It's like trying to carry a gallon of water across a parking lot in a wicker basket. So, when satellite imagery confirmed that the Qosh Tepa Canal, Afghanistan's 177-mile, multi-billion-dollar man-made river, was being dug straight into the raw earth without a single inch of lining, the collective intake of breath from the international community was audible. To Western observers, this wasn't just a billion-dollar leak. It was proof of a failed state doing what failed states do best, failing. But for the planners in Kabul, this omission wasn't a mistake. It wasn't an oversight by an amateur workforce or a lack of understanding of fluid dynamics. It was a cold, hard, and incredibly risky calculation. They knew exactly what the World Bank manuals say about unlined canals. They knew that in a sandy environment, you can lose anywhere from 30 to 60% of your water volume to seepage before it ever reaches a farmer's field. They knew that an unlined canal is a living wound in the earth that requires constant, backbreaking maintenance. And yet, they chose to leave the concrete in the silos. Why? Because when you are operating under the heaviest sanctions on the planet, with no foreign aid, no international credit, and a population on the brink of famine, best practices are a luxury you literally cannot afford. In the Afghan context, a perfect, concrete-lined canal that costs $2 billion is a fantasy that will never be built. An unlined, leaky canal that costs $500 million is a reality that is currently flowing. This is the story of the greatest engineering gamble in modern history, a project that defies every modern standard of efficiency in a desperate, blunt force bid for survival. We are looking at a billion-dollar leak that might, against all odds, be the only thing keeping a nation from drying up and blowing away. To understand the scale of the gamble, you have to understand the physics of the Afghan desert. The northern plains of Afghanistan aren't made of the rich, heavy clay you might find in the American Midwest. This is loess and sand soil that is porous, thirsty, and structurally unstable. When you pour water into a trench cut through this kind of terrain, the water doesn't just sit there. It begins a process called seepage, where gravity pulls the liquid through the microscopic gaps between soil particles. In an unlined canal of this magnitude, 152 meters wide and 8.5 meters deep, the pressure at the bottom is immense. That pressure acts like a hydraulic press, forcing water into the ground at a rate that would make a Western irrigation engineer lose sleep. We aren't talking about a few drips. We are talking about a massive underground river forming beneath the canal, siphoning off the very resource the project was designed to deliver. Then, there's the atmospheric tax. The sun in northern Afghanistan is relentless, and the wind is a constant, drying force. Because the Qosh Tepa is so wide, it creates a massive surface area exposed to the air. In a concrete-lined canal, evaporation is your only enemy. In an unlined one, you are fighting a two-front war. The sky is pulling the water up, and the earth is pulling it down. International hydrologists, looking at the project's dimensions, have estimated that during the height of summer, the canal could lose a staggering amount of its initial intake from the Amu Darya River. If you start with 100 units of water at the intake gates, by the time you reach the tail end of the canal, 285 kilometers away, you might only have 40 or 50 units left. To a project manager at the Bureau of Reclamation in the U.S., that 50% loss would be a career-ending disaster. It would be viewed as an objective failure of design, a waste of capital, labor, and a precious regional resource. But there is a secondary physical reality to this leak that is even more dangerous: the integrity of the canal itself. Water moving through an unlined bank isn't just disappearing, it's changing the soil's chemistry and structure. As the water seeps through the sides, it can cause the banks to slump or collapse, turning a precisely engineered channel into a jagged, muddy mess. Without the rigid protection of concrete, the Qosh Tepa is essentially a 177-mile-long erosion event. The Afghan planners are essentially betting that they can move the water faster than the earth can swallow the canal. It is a race against entropy. They are operating on the edge of a physical limit, using a brute force approach to hydrology that assumes that if you just throw enough water into the system, enough will eventually survive the journey to grow a crop of wheat. It is an engineering philosophy that values volume over velocity and survival over sustainability. But what if the leak isn't a bug? What if, in the strange, inverted logic of a drought-stricken nation, it's actually the primary feature? This is where the Afghan counterargument begins to take shape, and it's a theory that turns Western hydrological efficiency on its head. They call it the battery theory. For decades, the groundwater levels in northern Afghanistan have been cratering. In provinces like Balkh and Jawzjan, ancient wells that sustained villages for centuries have gone bone dry. When the rain fails, which it does with increasing frequency, there is no backup. The earth is essentially a depleted capacitor, a giant storage unit that has been drained of its lifeblood. By digging an unlined canal, the Afghan planners are effectively using the Qosh Tepa as a 177-mile recharge strip. Think of it like this. In a standard American irrigation project, the goal is to get water from point A to point B with zero loss, so you can precisely water a specific field. It's a pipe mentality, but the Afghans aren't just building a pipe. They are trying to resuscitate an entire ecosystem. As that water seeps into the loess and sand, it doesn't just vanish into the void. It descends into the water table. It begins to mound under the canal and spread laterally, miles into the surrounding desert. Suddenly, a farmer 3 miles away from the canal, who doesn't have a direct irrigation gate and isn't part of the official project, notices that his dry well is starting to fill back up. He doesn't need a government pump, he just needs his old bucket. By leaking on purpose, the canal is providing a decentralized, invisible form of aid that a rigid, concrete-lined system could never offer. This is the ultimate survival hack. In a country where the central government's ability to manage complex, micro-level irrigation networks is hampered by conflict and lack of tech, the ground does the distribution for them. The soil acts as a massive, natural filter and reservoir. Unlike an open canal, groundwater doesn't evaporate. It doesn't get clogged with silt. It doesn't require a technician to turn a valve. It just stays there, held in the pores of the earth, waiting for a thirsty root or a local well to find it. From this perspective, the $1 billion omission of concrete isn't a loss of efficiency. It's an investment in regional resilience. They are betting that the long-term benefit of a raised water table across thousands of square miles outweighs the short-term waste of river water. It is a radical, almost geological approach to infrastructure, where the goal isn't to control the water, but to let the water reclaim the land. This fundamental disagreement over whether the canal is broken or brilliant reveals a massive rift in how we define success. In the West, we are obsessed with efficiency metrics. If you're a project manager at a firm in Denver or a consultant for the World Bank, you live and die by the percentage. You calculate the return on investment down to the second decimal point. You measure cubic meters per second lost versus dollars spent on lining. To a Western engineer, a system that loses 40% of its volume is a scandal. It's a waste of taxpayer money and a violation of the do more with less mantra that governs modern sustainability. But in Kabul, they aren't looking at efficiency, they are looking at existence. They are operating on a survival metric where the math is much simpler. Some water is infinitely better than no water. There is a certain arrogance in the international critique that assumes Afghanistan is simply too poor to do it right. It ignores the fact that doing it right, by Western standards, would have killed the project in the cradle. Adding a concrete liner would have tripled the cost and added years to the timeline time the Afghan people don't have. This is the sharpest piece of social commentary the Qosh Tepa offers. Our global standards for good infrastructure have become so high, so expensive, and so laden with red tape that they are practically useless for a country in a state of emergency. We've turned engineering into a luxury brand. We say, if you can't build a state-of-the-art, lined, sensor-monitored, climate-controlled canal, you shouldn't build one at all. The Afghans have looked at that logic and rejected it. They've embraced the good enough model of the 20th century. This is infrastructure as a blunt force instrument. It's messy, it's inefficient, and it's arguably reckless by the standards of a California water board. But it's also an indictment of a global development system that has forgotten how to build for people who are starving today, not for donors who want a clean audit tomorrow. By choosing the unlined path, the Afghan government is making a statement. We would rather have a leaky, primitive lifeline that actually exists than a perfect, high-tech blueprint gathering dust in a drawer because no international bank would sign the check. It's a gamble that prioritizes the now over the forever. And in a desert on the edge of famine, now is the only thing that matters. However, every gamble has a house edge, and in the case of an unlined canal, that edge is a phenomenon known as salinization. This is the hidden trap, the environmental landmine buried beneath the battery theory. To understand the risk, you have to realize that the Afghan desert isn't just dry. It's ancient. Over millennia, as water evaporated from these plains, it left behind concentrated deposits of salts and minerals deep within the soil. Under normal, arid conditions, these salts stay dormant, locked away in the lower strata of the earth. But when you introduce a massive, unlined leaking canal into the mix, you change the underground pressure. As the seepage mounds and the water table rises, it acts like an elevator. The rising groundwater dissolves those ancient salts and carries them upward toward the surface. When that salty water reaches the root zone of the crops, or worse, when it reaches the surface and evaporates, it leaves the salt behind. Within a few years, a field that was once a lush, green promise of food security can be transformed into a white-crusted wasteland, where nothing, not even the hardiest wheat, can grow. This isn't just a theoretical worry. We've seen this movie before in the Indus Valley of Pakistan and across parts of Australia's Murray-Darling Basin. In those regions, unlined irrigation systems led to waterlogging and salt toxicity that took decades and billions of dollars to remediate. For Afghanistan, the irony would be devastating. The very water intended to end a famine could permanently poison the soil of the country's most important new breadbasket. The planners in Kabul claim they are monitoring this, but sophisticated soil salinity management requires more than just a shovel and a prayer. It requires a network of drainage systems, essentially a second canal system, to wash the salts away and move the saline water out. But building a drainage network is even more expensive and less photogenic than building the canal itself. In the rush for a headline-grabbing victory, there is a very real danger that the drainage component will be sidelined or ignored. If that happens, the great seepage gamble won't just be about losing water. It will be about losing the land itself. The billion-dollar leak might provide a few years of bumper harvests, only to leave behind a toxic landscape that won't be able to support life for generations. It is the ultimate short-term gain, long-term catastrophe scenario, and it is the shadow that hangs over every kilometer of excavated dirt. Even if the salt stays in the ground, and the battery theory works exactly as hoped, the Qosh Tepa faces a second, more relentless enemy: time. There is a reason why modern engineers view unlined canals as living structures. It's because they never stop changing. A concrete-lined canal is essentially set and forget for several decades. It holds its shape, resists the current, and stays where you put it. An unlined canal is the opposite. It is a 177-mile-long battle against the laws of erosion. As the water flows, it will naturally try to widen the bends and deepen the floor. Silt, carried down from the Amu Darya, will settle in the slower-moving sections, choking the flow and raising the bed. Without the rigid protection of concrete, the canal isn't a fixed piece of infrastructure. It's an artificial river that wants to revert back to being a wild one. This creates a maintenance trap that could eventually bankrupt the very government that built it. To keep an unlined canal functional, you need a permanent, massive fleet of dredgers and excavators working year-round to remove sediment and reinforce the banks. You need a stable supply of fuel, spare parts, and specialized labor to patch up blowouts where the water has breached the sandy walls. In a country under heavy international sanctions, where every gallon of diesel and every heavy-duty gear has to be smuggled or bought at a premium, the cost of just staying still can become astronomical. It's the classic mega-project paradox. Building the canal was a one-time feat of national will, but maintaining it is a never-ending tax on a fragile economy. If the maintenance slips, if the excavators sit idle because there's no fuel, or if the silt isn't cleared for a single season, the canal's efficiency will plummet even further. It will become a series of stagnant, salt-choked pools rather than a flowing lifeline. This is the sustainability gap that Western critics point to when they call the project reckless. They argue that the Afghan government has built a machine they don't have the long-term resources to oil. But from the perspective of a farmer in bulk, this is an academic concern. To him, a canal that works for 10 years and then fails is still better than a desert that offers nothing today. The maintenance trap is a problem for the future. And in Afghanistan, the future is a luxury that has rarely arrived on time. The gamble remains. Can the immediate agricultural boom generated by the canal create enough wealth to pay for its own upkeep? Or are they simply digging a very long, very expensive grave for their own ambitions? Ultimately, the Qosh Tepa Canal is more than just a hydrological experiment. It is a mirror reflecting a nation that has decided to stop waiting for permission. The Great Seepage Gamble is a blunt, messy, and arguably dangerous middle finger to the global order. It is a project that says, if the world will not help us build a perfect future, we will build a flawed one ourselves. Whether it is a billion-dollar leak or a stroke of survivalist genius depends entirely on your vantage point. If you are sitting in an office in Washington, D.C., looking at satellite data and efficiency spreadsheets, it looks like a slow-motion train wreck, a wasteful, unlined disaster, waiting for the salt to rise and the banks to fail. But if you are an Afghan farmer watching the water table rise for the first time in a generation, the leak isn't a failure. It's a miracle. We often think of infrastructure as something static, as concrete and steel that outlasts the humans who built it. But the Qosh Tepa is something different. It is an infrastructure of now. It is a physical manifestation of raw pragmatism in a world that has largely abandoned the country to its own devices. Yes, the water will seep. Yes, the salt might rise. Yes, the maintenance costs will be a crushing burden for a cash-strapped government. But for a country that has been defined for 40 years by what it couldn't do, the act of simply moving water across a desert is a transformative event. It changes the psychology of the region from one of managed decline to one of active, if reckless, growth. In the end, the billion-dollar leak might be the most honest piece of engineering in the world today. It doesn't pretend to be sustainable in a way that satisfies a green energy consultant. It doesn't pretend to be best in class. It is exactly what it looks like: a desperate, mud-caked gamble for bread and stability. Whether it becomes a flourishing breadbasket or a salt-crusted reminder of overreach, it has already achieved its primary goal. It has forced the world to look at Afghanistan and see something other than a war zone. It has forced us to acknowledge that necessity has a logic of its own, one that doesn't always fit into a concrete liner. The water is flowing, the ground is drinking, and the gamble is in full swing. In the Afghan desert, they've learned that a leaky bucket is better than no bucket at all, as long as you keep pouring.